We're going now.
Sounds good. I'm sharing my screen. All right, I want to thank you everybody for coming to this workshop. We're going to have a review of community-based 3D printing for COVID-19 relief. As you know, we're all in the midst of a really intense crisis, something most of us probably have not experienced in our life. And we have a lot of community needs we haven't anticipated. We have a shortage of supply chains that our communities are facing. And we have a lot of difficulties that community leaders are beginning to step up with. And I wanted to give us a chance to talk to those leaders in each community to hear about their experiences and how they've gotten started. And when I say community leaders, I really want to be clear, and this is something I love working with smart communities. First of all, we're with US Ignite, but these community leaders have stepped up from all sectors within their communities. You're going to hear from people who started out with First Robotics team, all the way up to people who run big businesses to do these types of production chains. And that breadth of experience and the ability to tap into that at a local level has been invaluable to helping alleviate some of the pressure with shortages for equipment within our various communities. So welcome here. I want to introduce myself. My name is Scott Turnbull. I'm with US Ignite. We're a nonprofit out of District of Columbia here in Washington, D.C. We help accelerate the smart city movement, and we work with communities and application developers all across the nation, whether that be cities, smart bases, counties, or even entire states. With me, I have my colleague, Lee Davenport. Lee, say hi.
Hey guys, thanks for joining today.
Thanks. Lee is going to help take questions for the panelists. So if you have a question during this time, please go ahead and use at the bottom of your screen, you should see an icon that says Q&A. Open that up and use the Q&A feature. And you can send that directly to Lee, who will curate those questions for our panelists as we get going. So thank you, everybody. It's great to have you here. I'd like to introduce our panelists, and then we'll go through each one of them in turn to talk a little bit about their process in 3D printing and how what their pitfalls might be and so forth. I want to introduce first Jake Blend. He's a pandemic expert. Hey, Jake. He's a pandemic expert with Generator Makerspace in Burlington, Vermont. They're printing masks and shields, I believe, for UVM Medical Center. So welcome, Jake.
Thank you.
I'll let you talk about your process in a second. We also have Jim Smith with Clario. They're printing open source personal protective equipment in the Triangle region of North Carolina. Thank you very much, Jim, for joining us. We have Shejin from the Astromex team under First Robotics, who is printing personal protective equipment in Kansas City for the Kansas City Medical Center. So you're using open source plans as well. So thank you for joining us. We have Spencer Lovelace. He's the CEO of Dustless Technologies. They design and manufacture wet and dry HEPA vacuums and dust collection shrouds for hand tools. Dustless is supplying 3D printed masks and filters as an alternative option to N95 masks that are not widely available. And we also have, I think he might be joining us here, Trevor Elliott from UC. He's UC Foundation Professor of Mechanical Engineering, the College of Engineering and Computer Science at the University of Tennessee at Chattanooga. So thank you everybody for joining us. We really appreciate you taking the time to share your expertise with the communities here. I'd love to start a little bit with Jake, please. Jake is from Burlington, Vermont. Jake, tell us a little bit about yourself, how you got started in 3D printing, how you're connecting with your agencies, and talk about your process quickly for the group.
Myself or my shelf, just making sure this is my 3D printing shelf, rapid prototype shop lead or engineer, or I'd say was before our makerspace had to shut down its public operations, and really been pushing for this kind of open source medical supply group. I joined a little while ago and kind of took off from there, and it's been nonstop.
Excellent. Thanks. And Jim Smith with Clario, please introduce yourself.
Yeah, my name's Jim Smith. We are a software integration company. We focus on big data and analytics, and just happened to be a hobby of mine, 3D printing. and had access to a couple of printers. Through some of the work we did at Clario in the medical space, I started to engage with some physicians and ask if there was a need for a face shield or a particular device. I was kind of surprised. I thought initially they'd come back and say, nope, don't need that. What we found out is they had a desperate need for the face shields.
And Jim, correct me if I'm wrong, but you connected with a local high school team to get them helping with this process. Is that not right?
We did actually. There's a local high school a few miles from where I live, which is very convenient. And it's Apex Friendship High School, fairly new high school. And they have an Academy of Engineering Technology. And so that program has half a dozen printers. And the challenge they have right now is some of the printers are at school, some of the printers are in transit, so they're trying to get up and operational. We've also got the startup community in the Raleigh-Durham area that's really stepped in, and we're producing the face shields at a much faster rate than just my machine. Great.
And I also have Sajin Seberg with the Astromex team out of First Robotics. Sajin, welcome. Introduce yourself and I already have a question about what is First Robotics, so maybe explain that to folks.
Yeah, sure. So I guess I'll start with that. So I'm on the Kansas City Astromex. We're a First Tech Challenge team. First is an organization that basically is like a robotics competition, I guess, and they provide 4 different leagues for 4 different levels of competition. And I guess I can talk about my connection with KU Med, if that's fine.
Yeah.
So last year, my dad was diagnosed with acute myeloid leukemia, and we became friends with one of the doctors who did his bone marrow biopsies. And so then through knowing him and actually becoming friends with him, or at least my parents were, we found online this open source stuff. And we basically asked if there was a need for this, and turns out there was. And so they asked if we could we asked if we could be of any help for that. And so through our robotics team, we were actually able to use our social media and all that stuff and our connections within the robotics community to basically start crowdsourcing 3D printed parts for a face shield.
That's great. That's great. I'd like to introduce Spencer Loveless. He's the CEO with Dustless Technologies. Spencer, talk a little bit about your shop and your effort to get started. I believe you're going from molding over to 3D printing. Is that right?
Yeah, that's our goal. We desperately want to get away from injection molding. And so we've been in the search the last 12 months, pretty heavy to really bypass injection molding. We found a couple great options that are looking very, very promising, that we're going to be releasing some products in the next few months we're looking at rubbers and rubber-like materials, as well as hard plastics. And so we're a vacuum manufacturer, and we're supplying we're supplying filter material and filter media for the COVID virus. But yeah, we're excited.
That's great. So you're actually doing filters. That's you're actually in the filter supply, or the mask to hold the filters?
So we're currently doing filters, but we're also getting into masks. I mean, there's so many different options here, as well as face shields. But
okay, great. Thank you so much. I also have Trevor Elliott. Trevor Elliott is a professor at UT, University of Tennessee at Chattanooga, head of their Fab Lab, if I understand it right. Trevor, you're with us?
Hi, can you hear me?
We can. Welcome.
Okay, awesome. Thank you for the introduction. Sorry, I'm actually driving back to one of our labs to reset a piece of equipment, so I'm on the road right now.
Sure.
So I guess a brief intro of some of the stuff that we're working on. We are working on some of the same initiatives as the THEC initiative, which is basically the 3D printing of the face shields. We also have, I happen to teach the interdisciplinary design course at UTC for engineering students. So I have approximately 30 students that are divided up amongst 3 different projects, one pertaining to basically the creation of end-to-end respirator using readily available products that are not already currently used for respirator construction. As well as some of them are looking at additive manufacturing of ventilators, everything but the motor and the control systems. And the other of the 3 groups are basically looking at methods to create or otherwise utilize larger versions of N95 filtration systems to reduce them down for single point of use for persons.
Okay, great. Thank you so much. And so I'd like to come back to sort of the top of the list and get a picture for your manufacturing setup and what your capabilities are and what you're specifically manufacturing. So Jake, you started out, I think, at the Fab Lab, but that's closed. So you went about a process of getting a hold of some other printers. Is that right? I mean, what was that process like? And if someone's in a community looking to do this, how could they go about that?
It's quite a combination of being one of those people in the right place at the right time, as far as the face shields and our ability to whip those out pretty quick. We have 2 laser cutters. I'm pretty good with plastics from just art, really, and other things I've been doing and experimenting as a materials engineer resource for the community. So it made sense that that would be a great place to kind of start that. We had a lot of contact with UVM Medical Center and some really good advocates there that went to get these, approved feedback and iterative design back and forth, up and down the hill here in Burlington, driving up under, don't go out, quarantine, stay isolated. This is my first Zoom meeting. I'm sorry.
No, that's fine. That's fine.
I've been running around a lot.
That's fine.
I hope
so
that answered the question a little bit.
It did. So it's that medical professional that did the approval of the device. Is that how that went back and forth?
It's part of the design approval team and hazards and materials team, and a couple other titles and groups, but really good contact of a person that would really advocate for the maker community and this distributed manufacturing, and we're all seeing it come down. So having that first line of contact on both sides, having us talk and meet,
great,
and having that approval with the hospital at leveling.
It's fine.
But having that person at the hospital and having what your local medical professionals actually need, and not just designing for what you think they need or what you hear in the news. Talk to your community as these supply chains are closing, state borders maybe even.
Right.
Get in touch with your community first.
Great. Jim, I wanted to touch base with you. You said that, so these are distributed people helping you out. This high school students especially, are they using their own devices? And how did you go about getting sort of the plans for it and getting them approved and getting that coordinated set of people working together? Could you talk a little bit about that?
Yeah, largely what I wanted to do is take some of the open designs that already existed. So we started with the Prusa design. There's a Prusa headband. It takes about 2.5 hours to print. And then I ran that by the physician at the emergency department and told him, the timeline and how many we could produce a day. And he basically came back and said, that takes too long. He said, these are disposable. He said, we're going to use them for a case or a couple cases, and we're going to toss them in the trash. So he said, is there anything you can do to increase the amount of quantity that you're actually generating? And so I said, let me do some things. Let me look around. So I found what we call the slim design, which is floating around out there, and printed that in about an hour. The problem with that is we couldn't attach the face shield very well. So what we had to do is make a modification to the pin so that it would actually kind of put some tension on the PVC face shield as we attached it to the top of the band, and then it held that in place. So tomorrow will be our first delivery, and these are to the VA hospitals. And so we'll be delivering 40 to the Durham VA, and then we realized that there's a significant shortage at the Fayetteville VA in North Carolina. And so we'll be distributing half, so 40 to them. Next year, or next week, we should have 200 or 300 going out, and we'll split those among the facilities as well.
That's great. That's great. And Sergeant, so you had you're I mean, you're really a grassroots effort. So can you talk a little bit about what your setup is? Is it like filament or resin? Where'd you get your plans, and how you, is there any process you go through? Are they throwing those away too? Or are they sanitizing between uses, or do you know anything like that?
Yeah. So I don't know much about what happens after we give them to KU Med. We just know that we're in charge of basically gathering them all, assembling them all, and then once they have them, it's up to them to do whatever they want. Like Jim, we're using the Prusa design. Actually, unlike Jim, we're using the Prusa design. And so we know that they do take like a long time, but we figured if we could get a lot of people in on it, then we could get those mass produced. And so currently our goal is to hit 800 for KU Med. We have some other hospitals who are interested as well.
Who's we in your case? Who all is on your team?
It's basically myself, my mom, robotics mentors, and then another family friend. But basically we're working alongside Dr. Collins, who's our contact for KU Med, basically asking them what their needs are and then going on from there.
Okay, great. I'd like to turn to Spencer. Spencer, your situation seems to be a little different. You're a manufacturing company to begin with, so it seems like you have a lot of scaling and you have a lot of experience in this already, especially around injection molding. So how did you get that switch, that context switch to this, and how did you connect with the medical professionals? What's substantively different about your process if other industrial or business manufacturers are looking to get into this?
So, I mean, two-part question. So
Yeah.
the medical, I'll answer in a second. But the reason for switching to 3D printing is we do either our injection molding either in Salt Lake or in China. And injection molding, people are like, oh, if you 3D print, you don't have to pay for your mold. And to us, that's a very, very small portion. But that is a portion. We don't have molds. We don't have lead times. We don't have inventory that we have to prepay. We can change designs on the fly. We can make it. I mean, I have big companies coming to me and saying, hey, you have a really cool product. Can you put our name on it? And I'm like, I can, but you have to order thousands of them, and you have to, you're going to have to wait months for all this stuff. I mean, we deal with big companies, Bosch and Milwaukee Tools and stuff like that. And I would love to our goal is to go to them and be like, oh, you want a product? We can design it, we can print it, and you will have your finished product within 3 weeks if you approve it. And so, we're looking at doing that to help us on our side, both the small stuff, which we're more leaning toward the photo initiative resin stuff because we can print much faster than FDM. But we're also looking at large scale, like we have 3D printed a vacuum that will go on top of a 55-gallon drum, like the whole thing. And so very large FDM printers as well, post-processing stuff there. And so in this, I mean, it kind of goes hand in hand with what we're doing with the world wants masks and shields and everything, and they need it now.
Right.
And that's exactly what additive manufacturing is.
But how does, as a business owner, how do you deal with a context switch? Is that a standard business practice for you, or was there something special about this to get your factory realigned, to get your staff training realigned, to get your supply chains and distribution chains connected to this output?
Are you talking related to the COVID?
Yeah, related to COVID. Yeah.
Fortunately enough, we have a lot of supply of filters, and they're high efficiency filters. So currently what we're doing is, we're repurposing our filters. If you go to our website, we have a link at the very top, and we're making some videos to show how we're taking a wet dry vacuum bag and we're repurposing it for the COVID filter mask inserts, basically. And now we have very large companies that are needing filter material as well, because that's one of the bottlenecks in today's in today's world.
Great.
But there's a lot of repurposing, a lot of restructuring, and you just kind of have to go with it.
Quickly, where did you get your plans from? Are those open source plans, or did you get an industrial plan somewhere?
So as far as our filters, we just kind of modified and went with what we had. We have ultrasonic welders in house, and we just kind of welded some plans for the filters. But we are working with the mask manufacturers. There's one, liracing.com. Matt Mendez, he designed a filter there's many of them out there that you see on social media, but that's kind of the one that we've went with for the second venture on 3D printing masks. Yep.
Okay, great. Thank you so much. Trevor, so I'd like to hear about your background. You're printing, if I understand it right, from the University Fab Lab. Talk to us, who's engaged in that print process with you? How did you develop the build process? Where did you get your plans from? And how are you doing the approval of these devices to get to the medical professionals? Is there somebody in the loop there?
So originally, this for us started out as that Tennessee Higher Education Commission initiative to make the Prusa headbands, which I've already heard somebody discussing earlier. I was kind of interested to hear the thin version of it. We've actually been able to produce ours with changing the infill slightly and changing how we're doing support structures and whatnot to get them down to about an hour and 10 minutes with the original file. So we're basically just cranking those out on some of our old school systems that we have. I'm literally running MakerBots that are printing that stuff out.
That's great.
In addition to that, we've got some other equipment that we're leveraging. I've got to reach out to them in terms of the actual shields themselves. So they've kind of compartmentalized this effort and basically sent out the files specifically to certain entities to provide certain parts. And so I've reached out and said, look, we have laser cutting technology. I could probably within 24 hours, 48 hours adapt a roller to it and sheet feed it or roll feed it and actually automate a process to cut more of the shields themselves. So there's some things out there that we're still kind of working on from that perspective. Outside of that, we've and one of the ideas I had suggested to some of our students that involves a respirator. Getting back to that, how do you produce them faster, and kind of some of this discussion about injection molding and things of that nature. And we happen to have a rather large format vacuum forming table, and I had suggested to some of our teams that they could develop either 3D printed and or using our CNC router some molds that we could put in that. I could probably multiply the output of the 3D printed aspect by at least 10 times in terms of the output per day, so long as we had the sheets to put in there. So that's one of the other efforts we're looking at there. In terms of the vetting of the equipment, we have been in conversation with some of the folks here at Erlanger. Outside of that, it's been relatively limited. Most of the things we're connected to are initiatives that were started by other folks other than some of my design students that I've got working on some separate projects that we may seek medical information on in the near future.
That's great. And actually, this is for anybody here, especially the people using open source plans. I noticed that the NIH has a document portal site that has open source plans available for face shields, but almost everybody I'm talking to is using the PERSA version. So what's the advantage of PERSA? And for anybody who can't see, Jake's actually doing an assembly on camera as they're talking, but what's the driver to PERSA over NIH for people like me who are uninformed?
Prusa is amazing as far as a really robust, popular, adopted printer. It has a very large community worldwide. Oh, and guess what? It's in a spot that might have had this COVID right before us. So they know what they're doing. They have a printer farm and they were able to make these shields, right? What we got back from UVMMC was not just having the front and the brim here. There's some cool stuff. It comes out like daily. This is the print heard around the world, I would say. This top part, no droplets coming in. It's the origami kind of style. It folds up, protects the top, so you don't have to print a brim here if you don't want. Now, last night came out the American version I've been pushing for. You ready for the secret sauce?
Sure, go ahead.
3-hole punch overhead transparencies. Get them now, people. 3-hole punch.
Okay, great. And so Jim, I'd actually like to ask you, so normalizing the assembly process seems especially like the masks require a lot of assembly, and that seems to be a stumbling block for a lot of people getting in. With this distributed shop, how are you normalizing? Are you distributed instructions? How are you getting everybody to do the same sort of assembly process?
Yeah, so like I said, we've evolved the designs from the Prusa design to what we call the slimline design. It's similar to what Jake showed, we have a few differences, and we're going to be releasing that. If it's not out already, keep an eye on, we put up a website, faceshield.clario, KLARRIO.us. We talk a little bit about the project and the contributors, and we have a small section there for makers, and we will be putting those either the drawing file and or the STL for people to use. But what we did is we standardized on the design, and then we got a group of contributors, and we basically just manage it all through a Google Sheet. And so we have everybody listed there. We have their contributions by week and what they expect to, if they're having equipment outages, things of that nature. The other advantage to the slimline design, as Jake brought up, materials are becoming very scarce, right? So we use materials filament for the printer, and you know, by using the slimline design, we can use a fraction of the material that the Prusa design uses in a fraction of the time. The other thing is the actual PVC or whatever you're going to use for that front, that shield portion. Those are constantly, you're having to find new sources for those. We use binder covers, unpunched binder covers, and then we use a 2-hole punch. And we use a 2-hole punch on either side, and we've got those calibrated. So essentially the makers all, they print to a specification that we've provided, and we've asked them to calibrate their machine so we understand that they will actually produce a part that we've designed within a certain tolerance. And then we have some flexibility in our design that we know the actual shield will still work. The last component of it is a rubber band, and that's pretty straightforward. So those are pretty easy to source.
Great. And we'll be putting up resources, links to resources along with this video that's being recorded after the meeting today, later tonight or early tomorrow. So people can look to that on our US Ignite website, and I'll link it and mention at the end of this for these resource links that we'll be putting up. Seijun, I wanted to let me get something about your build process. What's your best advice for especially people trying to home source this? What's your biggest advice for avoiding pitfalls or getting up and running as quick as possible, sort of given that reality?
Yeah, I would say make sure you have a contact with a hospital or wherever there is need before you start going and making these. That way they know what they're going to be getting. So I had to print 2 or 3 different designs to present to my contact before getting approval for that Prusa design. After we print these 800, we'll probably move to a slimmer design, but since we've already gotten approval for this particular design, we're sticking with that until we reach our current goal. I would say just make sure you're on top of things because you'll get emails or contacts from like a variety of different people. And there are companies that are going to be reaching out to you most likely if you're starting a grassroots campaign as well. Sure. And so managing that transition from becoming a grassroots campaign to somebody who knows what they're doing and gets paid to do that for a living, I guess. So, yeah.
That's great. Actually, speaking of that, so I'd love to go to Spencer, your advice on pitfalls for industrialists, but I really love to hear broadly, you know, companies think more broadly about sort of what are their options here. Is there any advice you have for people running a manufacturing shop that maybe options that they have available now that aren't normally there? Maybe there's loan structures around subsidizing some of these costs over time or business practices they can adopt, but what are your pitfalls or your advice?
So, I mean, obviously return on investment is a big one right now. Can I share my screen? I'll show you some of the things this is a big pitfall that we're trying to overcome. Can I show you?
If you have the option, sure. Go ahead, knock yourself out.
Let me see if I can reverse my camera. Okay, so I'm gonna walk into our conference room and I'm gonna show you all of these components that we have tested and broke, trying to find the perfect resin that mimics nylons and ABSs and polypropylenes and everything that exists in the thermal industry. Like we've tested hundreds and hundreds of components trying to break them and trying to find these materials that people are like, yeah, we can mimic that. And we're like, let's see it. And they send us parts and nothing really exists that challenges the current business structure or the current manufacturing methods. But that's one of the big pitfalls that we're overcoming, and we think we found some really great solutions to overcome that.
That's great. That's great. And Trevor, let me ask you on, so especially coming from the educational sphere, are there advices on your build process that you would give people to avoid pitfalls? And especially from the education sphere, is there some benefit or some resource that people coming from that pillar have available that maybe they don't work, like grants or federal funding or anything like that that can help subsidize this?
Great question, and kind of mirroring back to what one of the other folks said about reaching out to your local people to see what they need. I think searching around for some of the initiatives that already exist is a great place to start. I've had, I think, about 5 different individuals just through some of the things I've shared on social media about that THEC initiative that we're involved in. And they have reached out and said, hey, I've got a printer, or I've got this, or I have this resource. How can I be beneficial to this? And also mirroring that same statement, once they, do start sending you messages, it becomes relatively challenging to become the point of contact at that point, because you have so many different people coming from so many different directions. But you have to really watch that closely and get back to them as soon as you possibly can. I do tend to point back at some of the initiatives that are already going, because they usually use some of the open source stuff that's already been vetted, and they usually have access to settings already, or infill configurations that already they know work, and these people can actually just work to the same initiative and drop off their parts to a common drop point that you can then collect and send out to the organizations that are working on it. That's kind of been our approach to some of the larger scale solutions. The smaller scale solutions are more some of the stuff that we're kind of trying to evolve some of our own ideas about how to advance things within our local group, within our local couple of healthcare providers.
Great. So I'd love to, we have some audience questions that people have been submitting through the Q&A link that we distributed before. We've got some great questions. I'd like to ask Lee if he can sort of pick some of the questions that you think would work for the entire group. So Lee, what questions do we have?
Sure. Again, thanks again for submitting all these questions. We've got a load of them. I think to get started, we're going to shift a little from configuration over to production. Some folks want to know what's the volume of units you can produce on a day or distribute per day, and other folks would like to hear about payments that have been made. Are they payments changing hands are these all truly donations? And if they're donations or in production, are you restricted by the risks that the owner or the donated good may carry with it if the person gets sick while wearing it?
We might as well use the alphabetical list. So Jake, let's start with you. Any feedback on that question?
As part of a larger community now and a larger effort, I wouldn't be able to speak on that right now as an individual, especially as things change daily, even overnight. I think with just like say the FDA approving emergency FDA or emergency FFF and FFDM and FDEF printing, it takes all kinds, and things are moving really fast. To answer your question, the legal aspects of this, definitely get a lawyer on your team. Luckily, the Generator Makerspace is made up of a very, very strong board, and that board has come together to provide their strength and expertise in this. I'm just the guy that's 3D printing and helping coordinate this with the larger national, international movement, the open source medical supplies. I'm just there doing that. Legally,
Jake, what's your setup there? How many are you printing on that setup you have behind you?
Well, I'm kind of, I have a weird, let's say, third shift of this weird job I never knew I was applying for. Third shift design for shields around the world. So I'm working on what would be for us the fastest version until, say, injection molding catches up. And I got to catch up with someone after this that's saying injection molding is not the answer, and top molding. There's so many differing paths out there. It's a new world, and
Great.
Yeah.
So Jim, let me get from you. So how many are you making? I think you mentioned a number earlier, but especially with that.
So I personally, I have 2 machines. So I have one from the Riot Labs. I think you are familiar with the NC Riot guys here in Raleigh. And so early on in this process, they loaned me a machine to provision out. It still stayed in what I classify as the barn. It's actually a really nice barn, but my equipment's located over there. So I have a Anycubic that's running pretty much around the clock. It's a really inexpensive machine, but it's calibrated and it runs really well, and it just runs around the clock. So I get about 1 hour off that one. I'm getting about 2 off the, there's a LutSpot Taz 5 that's running. That's Tom's machine at NC Riot. And I'm getting, about 1 hour off that. I do a double design. And so I'm getting a couple an hour. So in a day, I can do 20, 25, something like that of these slim designs. We've got makers around the Raleigh-Durham area. And so they're all contributing. So we'll make, our goal right now is about 300 next week among the distributed makers that we have. And I think, as Trevor mentioned, we have a common drop-off point. So we use the Riot Labs. We're actually looking at setting up a second assembly point. So we're gathering all the materials for that. So we'll have an assembly point here in Apex, and we'll have an assembly point in downtown Raleigh. And so the respective makers can drop at a particular location, and we'll assemble those and distribute those.
And Jim, can you just remind me if you are donating or selling those goods?
Yeah, we are actually donating them at this point. So my company, we actually kicked in and early on bought the materials. So we created some of the material shortage. We realized that in the wholesale chain, the materials had already been gathered up, right? Most of the universities had bought those materials. And so the big sheets of, the PET was almost non-existent a couple weeks ago. And so we switched over to common, office materials and common filaments that we could get our hands on. Now the filament is really hard to get your hands on. So we have a stock coming in. I just received some today. So again, with that slimmer design, it really helps us conserve the materials.
Great. And Sajin, actually for you, how are you subsidizing this? How are you keeping this running?
Well, basically, in terms of production, since we are like a grassroots campaign, it's basically everybody's doing their own part. So I guess in terms of money, everybody's doing their own part to pitch in rather than people purchasing them. And so like personally, I've got a printer of my own, and then people who don't know how to use a printer have actually donated a printer to me because I know how to use them. So I've got 3 in my basement right now running constantly. And I can get about 1 an hour as well. And so it's pretty crazy what like our community has been able to do. But in terms of like pickup as well, we kind of have a common pickup point, but again, there's like that fear of being out of their homes. So what we've actually been trying to focus on is letting myself or my robotics mentor do the pickups ourselves. And that way people can just set the design outside of their house. That way we can just go and pick them up.
That's great.
Yeah, it's really interesting. You mentioned people gave you printers. I get a lot of emails with pictures of boxes of parts that looks like a printer,
Yep.
and they're asking me if I can use it, and I'm like, no, I don't have time for this.
Yeah. It's wild.
Great. And actually, Spencer, I mean, the same question, sort of the throughput and the number of devices you're printing. I'd love to hear too. How are you? I assume you have a burn rate. You're a business, right? So you have to keep the lights on somehow. So how is that process running for you?
So we have, we're just getting to the production printers. We have, 5 or 6 printers from, Creality, cheaper printers that we absolutely love, and some more expensive ones. But really it comes down to the return on investment. And I mean, we are a business. We have to make money. We have a lot of inventory and employees, and would love to just donate everything we can. But, businesses just can't do that. Some can, I guess, many times, but we can't.
Sure.
But
sure.
It's just return on investment. Try to figure out what the machines cost, how long you depreciate them, what kind of loans you have to get for them. There's a lot of companies in today's world that are willing to loan. Anybody can get money.
Yeah, it's almost a crazy low percentage too, right? So that's great. And Trevor, same question to you. How many you're producing? What's your through rate? And how are you keeping the lights on? How are you paying for the material and the time and all that kind of stuff?
So for us, we're running a mixture of devices. I've got everything from a 3 MakerBot 2Xs to a couple Gen 5s. I've even got a Evo, Airwolf Evo running, and we're producing about 1 an hour and across the 5. So our output, so long as there's not any particular failures, which knock on wood, about 3 of those devices have been consistently outputting every hour without me having to do anything else but pop one off and start it going again. I have been doing them one off instead of stacking them. I started out with some stack files, and the stack files had mixed performance. So I went back to just doing the singles and going out and checking on it. So our output is in the realm of 50 to 75. We could probably, if I get the other 2 or 3 devices I got sitting out there on board, we could probably ramp that up and speed it up a little bit more and get up into the 100 to 120 a day. Somebody said something about their basement. One thing I would point out on that is I started out, and also to the point of not going out anywhere and limiting your exposure. I started out with 2 or 3 of these in my garage. They belong to the university, but in order to make my life easier, I have 2 small kids. I wanted to move them more central to me, so if it was a failure, I didn't have to drive 20 minutes one way just to resolve it. And I have a air quality sensing in my house, and it became very obvious that running any more than, say, 1 printer in a even attached garage that is fully insulated and separated from the rest of the living space is probably not a good idea for standard homeowners. So I'd point that out to anybody that's offering to do nonstop work in support of the efforts. Just make sure they're observing proper ventilation aspects. I have since, conveniently enough, since I'm the advisor to one of our racing teams, the Racing Monarchs, it's the SAE Baja team, we have a 30-foot trailer that I went and picked up and emptied all the Baja stuff out of it and basically set up a bunch of tables in there, ran a couple extension cords out of my house, and in my driveway I've got a mobile print shop making these things as pretty constantly as I possibly can, about 15 hours a day.
Yeah, you
Great.
know, Scott, Trevor brings up a really interesting point. I tried as well the stacked versions designs that are out there, and you know, I had problems with those as well. It sounds like a good idea. You know, you don't have to babysit the thing as often. You can go 4 hours and you get 4. I think the couple times that I tried to do it, I ended up throwing the whole stack out. So it is a bit of labor of love where you're out there, you know, this print finishes up. You've got to be out there to take it off and clean the bed or do whatever you do to the bed for adhesion, and then get the thing started again.
Great.
Totally.
And definitely watching an egg timer.
Yep.
Okay. Lee, next question.
Yeah, there's a couple of questions about the parts themselves. Here's a question from Dave. It says, is everyone on the panel producing PLA parts for their end users? And Deb in Chattanooga asked, where can she source some of these items? Particularly, she was asking about the elastic that holds the visor in place. In the back.
Yeah, I can take that. The elastic, the people were using button elastic early on, buttonhole elastic, I think it's called. Again, I called a few weeks ago around local suppliers and then online, and I'm not sure how much of that stuff's available, but it was gone a couple weeks ago. So we shifted over to an 8-inch rubber band, and so they work very well, very strong, especially in our case where they're not going to be used over and over again, and they're pretty economical. You know, we just have to take one out of a bag, we kind of loop it through a hole, and we're good to go. So I think try to be creative. The face shield was mentioned. I think Jake mentioned he's using the 3-hole transparencies. We are using what's called binder covers, unpunched binder covers. Last I checked, the supplier we were getting them from on Amazon are sold out. So I think I bought the last, I don't know, 10 packs or so that they had. But local supply, Office Depot and Staples and things, they have these sometimes. Try to get the clearest ones available. They come in different clarities.
You know, another question that came in there's been quite a few that have come up around CPAP machines. And again, this is a bit of a shift off of the masks. Several folks wanted to hear about CPAP as a mask respirator with adaptable 3D printed covers. Is anybody experiencing or having experience with CPAP or modifications?
My only experience was early on, I started down the ventilator route and I realized I didn't know enough about ventilators. And there was a lot of controversy over if you should be designing a ventilator from the ground up. So I kind of pulled out of that. I kind of pulled out of that discussion and moved to something a little bit simpler. You know, there's a lot of needs out there. The universities have released a number of designs that are actually built on some standard components, like a manual bag that gets kind of inflated, deflated. So there's some interesting designs out there. It just wasn't what I was ready to sign up for.
And Trevor, are you doing respirators?
We've got some students working in conceptual areas right now to kind of develop some of our own, but they do tend to circle around exactly what's been mentioned, which is essentially the kind of bottle respirator. So there's pre-existing components out there that can be used for that. We're looking at some other ways to do that, but as people have pointed out, there starts to become kind of the legal concern aspect starts coming into that. And also the concern for making sure that we're following appropriate medical protocols to ensure that the things that we're providing can actually do what they're supposed to do. Part of my teams have been tasked with locating all of the accelerated testing protocols and aspects pertaining to both ventilators and respirators, and they're supposed to return on that sometime this week. One other thing I wanted to point out, somebody asked about the elastic bands. Just, I guess, generic Vesuvius of useless knowledge that I am. The rocketry groups, if you have any people that fire rockets anywhere around you, like small scale rockets, some of the smaller systems use elastic bands as the shock cords. And I've already seen where NAR and EEE Facebook pages have been posting people that have been donating those elastic bands to people. So if you're looking for what could be enough to make, you know, maybe 20 or 30 masks possibly, depending on who has what number of shock cords and what length, maybe reaching out to some of your local clubs that do some of those activities might be useful as well.
You know, Scott, we do have Doug McClellan on the phone. I'm going to unmute your line. If you want to just give us like a couple of minutes on CPAP, I know, again, it seems to be something you can talk about.
Yes. All right. Can you all hear me?
Yeah.
All right. Listen, there is a big, and I'm getting some storm going on here in the Baltimore area, a big missed opportunity. And it's not as complicated as it looks. Basically, the CPAP machine is a kissing cousin of the respirator. Along with, there are multiple sources for solving a lot of these problems. Not only CPAP, but, you know, we all hear of scuba divers and scuba gear. The only difference between a scuba regulator and a CPAP is one's designed to work underwater, one's not. Their whole object in life is forward air pressure for about 11 cms. The most, I have extensive knowledge because I use it, I live on it, my life depends upon it. And I've had to help a lot of other people learn how to use it and figure it out. At this point, I know more than my therapists, who actually call me a lot of times to ask questions. The point is that on the newer designs, they've been evolving the mask design for many years. Well, the newer ones now have removable hose pieces on the mask. The masks are readily available. They have a circular snap-in piece. You can easily make in 3D this snap-in piece along with a filter on the end, the same type of filter in one-way valve you use on an N95 mask. And so a simpler cylinder one or a round one that you see on fire, you know, that they use in firefighters and things like that, along with the one-way flap valve on the end, is extremely easy to design and make. And you might say, I know in the Baltimore area, I'm working with some people here, and we have multiple manufacturing, like this other guy said, you know, going to China is kind of out of the question. It's just too long. in the Baltimore area, we have a lot of medical apparatus manufacturers that make the plastic, have the extrusion machines for making needle covers, all that sort of stuff. They have what they call in the CNC market dark rooms. They fill them basically with materials, come back at the end of the day, and they got a bin full of 2,500 needle covers. So that being said, if you take a 3D scanner and scan the snap out hose piece, then you've got a template to work with right there in 3D. We have a local company called SimQuest that is a supplier in the industry. One of the biggest problems I've run into in the making community, I'm finding almost absolutely chuckling amazing, is that the maker community and the professional engineering 3D manufacturing people, they seem to have this big void between them. There isn't very good communications at times. And it's like, oh, gee, we're on the same road. Why are we not talking? Well, yeah, that's a problem. Anyway, so that's it in a nutshell. And I'd love to help anybody if they want to venture into this. The reason is that the masks are already available and we just need an air filter. Yes, somebody, Jake, was raising your hand.
Communication wise, I think this really awesome group I joined in, part of the starting people of Artist Asylum here, the open source OSMS, open source medical supplies, really awesome group that is kind of collecting all this information, including what just came out. Scott, I don't know if we're Brady bunching here and how this works, but you know, the NIH 3D repository that's out, the Prusa site's a great place to watch as far as the pinnacles of what's happening as far as daily updates. And all that information is funneling definitely through OSMS. You got my contact information, just get that at the end somehow. And I want to help all of you link in. You're going to love it.
Just one last question I'd love to, and then I can wrap it up. But we have a couple people in chat, and the regular chat, they say they have access to 3D printers. One person has 30 available to them. A couple have 20. There's several other people who have said that. What's the best way they can get started with this, both to get the plans and connect to the medical professionals? So maybe Sajin, so how do they?
So basically, I mean, we already had a connection at KU Medical Center. So I would say reach out to local hospitals or those who have declared that they do need like this protective equipment, and then talk with them and do your own research online. Like we started with the Prusa because I have a Prusa in my basement right now. We found their Prusa design online and started from there and asked them if that would be something that they wanted, and they said that yes, that's what they would want. So I would say make sure you get the design approved by whoever you're working with before you start mass producing them, because then you might end up with just a bunch of wasted plastic.
Great. And Spencer, any last thoughts for the community about how they can get started, especially if they're locally sourcing this? What's their best pathway to get going on this?
I think the best thing to do is get 3D printers in everybody's hands, whether it's a resin printer, whether it's an FDM printer. I love giving like all my relatives, I'm like, give your kids a 3D printer for Christmas. They print. My kids print all day, every day, and it helps just in designing and printing, and it's awesome. That's the biggest thing to get started, is just get them in everybody's hands.
Great. Well, I want to thank you, and I want to thank everybody here who participated in this call today. I know we've got a lot going on, and people are really scrambling to sort of catch up to where the local community needs are. And when we talk about leadership in communities, it's really you and people like you in these communities that have always been the sort of the pillar of what community strength has been around. We look towards larger responses and larger coordination, which will be very helpful when that comes online, but getting our communities up and supporting our local first responders, our local medical professionals, that's really, it's a humbling and a great, an encouraging thing to see happening across the country right now. I just want to remind everybody that I'll be posting this as a recording to the US Ignite website after this meeting later tonight or early tomorrow morning. You can visit this, and I'll link some resources discussed, from the plans to the NIH plans or the PERSA plans, and links to people's websites. And if we have permission for follow-up contacts, we might facilitate the discussion there if you have additional questions. You can visit us at us-ignite.org. You can talk to anybody that's part of the smart Smart Gigabit Communities Program. We work with a partnership of 30 cities across the U.S. who are all dedicated to walking forward their advanced technology and their infrastructure to make a difference for people in their community. We know that we're going to have to restart all of this, all of our economies again here at the end of it. So we invite any community that wants to participate as part of the Smart Gigabits Community Program to reach out to us as well. You can visit us through our website, or you can reach out through info@us-ignite.org. I want to thank everybody again for their time today. It was great talking with you, and I hope this got somebody started 3D printing in their local region. We'll have some other in series like this in the future, so look for announcements from US Ignite for other topics that we'll be doing roundtable discussions on. Thank you again for attending, and we will talk to everybody soon. Thank you.
Thanks,
Thank
guys.
you, everybody.
Thanks, Scott.
Thank you.
Thank you.
Do, 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 do.